In this video, you're going to find questions and answers for quiz number 3 of Calculus 1. Enjoy. For the first question, we're expected to find any extreme values of the function f of x equals to x multiplied by square root of x minus 1. And these are the options. So our task is to figure out which option is correct. To start with, we have to figure out the domain of the function. And we can tell that since we are not allowing any negative value under the square root, so the least number is 1. 1 is a number that we can put there, and when we have 1, then the square root of 1 minus 1 is 0, so 0 is the lowest value for the function f of x. So the domain would be from 1 all the way until infinity. So that's the first point. Now the second point is we have to get the derivative of the function because we're looking for extreme values. So the first derivative is going to be square root of x minus 1 plus x divided by twice square root of x minus 1. To find the critical points CP, let square root of x minus 1 plus x divided by twice square root of x minus 1 equal to 0. And then we could just go ahead and reduce this, and what we will be getting is twice of x minus 1 plus x equal to 0, and this implies that 3x minus 1 equal to 0, but this implies that x equal to 1/3. However, 1/3 is not in the domain, so we're not going to bother with it. It's not in the domain. It implies there are no maximas. So there is no maxima because of the fact that 1/3 is not in the domain. The domain implies x equal 1 is the smallest value for x. So f of x is monotonically increasing. Therefore, the correct answer is A, option A. So option A is absolute minimum equal to 0 at x equal to 1 and no maximas. Let's go to the next question. For the next question, we're supposed to find the value of k in the function f of x equal to twice x minus 3k x to the power negative 2. We want to have a local minimum at x equal to 1. This function, this is given. This function has a local minima at x equal to 1. So we have to figure out the value of k. And these are the options, k equal to 1/3 and so on. One more time. The function f of x equal to 2x minus 3k multiplied by 1 divided by x squared implies that the first derivative of the function equals to 2 plus 6k multiplied by 1 divided by x to the power 3. And this implies that 2 plus 6k multiplied by 1 over x cubed equal to 0 for x equal to 1 and k equal to negative 1 divided by 3. This is the only way we can get 0 out of this left-hand side. Therefore, if we do the second derivative, then we're going to get negative 18k multiplied by 1 divided by x to the power 4. And this implies that f double prime of 1 equal to negative 18 multiplied by negative 1 divided by 3, and that's equals to 6, which is greater than 0. So this implies the function has a minimum at x equal to 1 for k equals to negative 1 over 3. Therefore, the correct answer is B, which is negative 1 over 3. Let's get to the next. For this question, we have to find the minimum value of the function f of x equal to x to the power 4 minus x to the power 3. And we have all the options for the correct answer. So we will start by finding the first derivative of the function, and that will be equal to 4 x to the power 3 minus 3 x to the power 2. Therefore, if we take x squared outside, then we will have between parentheses 4x minus 3 equal to 0. And from this, we can conclude that either x equal to 0 or x equal to 3 over 4 for the left-hand side to be equal to 0. That means these are two possibilities for the critical points. Now, if double prime will help us to find whether or not there is a minima and what is the value of the minima and so on. So if double prime of x equals to 12x to the power 2 minus 6x, we can conclude from this that f double prime of 0 equals 0 and f double prime of 3 over 4 equals to 12 multiplied by 9 over 16 minus 6 multiplied by 3 over 4. And that will give us 27 divided by 4 minus 9 divided by 2, which is greater than 0. One more time, if we just plug in 0 here, we can see that the coefficients are gone because we have a 0 in each term. So f double prime of 0 equal to 0. And f double prime of 3 over 4 is just a 12, and then we replace it over here by x squared. Instead of 3 over 4, we have 9 over 16 minus 6 multiplied by x, and in this case x is 3 over 4, and that will give us 27 divided by 4 minus 9 divided by 2, and that's greater than 0. So f double prime of 3 over 4 is greater than 0 implies the function has a minimum at x equals to 3 over 4. Thus, f of 3 over 4 equals 2, and we have to plug in 3 over 4 for the two terms in the function. So the first term will be 3 over 4 to the power 4 minus 3 over 4 to the power 3, and that will end up giving us negative 27 divided by 256. And if we look at the options, we find that to be option A. So the correct answer is option A. Next. For this question, using the second derivative test, classify the critical points of the function f of t equal to t cubed minus t squared minus t plus 2 and locate any points of inflection. These are the possible answers, and only one answer will be the correct one. So let's go ahead and search for that. First, we have to get the first derivative. F prime of t is going to be equal to 3t squared minus 2t minus 1. Now we have to solve this equation after equating it to 0 because we want to identify the critical points. So to find the critical points, we factor this quadratic equation, it will give us 3t plus 1 multiplied by t minus 1 equal to 0. That implies that the critical points are 2 at t equal to 1 and at t equal to negative 1 over 3. Now it's time to get the second derivative. F double prime of t equal to 6t minus 2 implies, if we check 1 whether or not it concaves up or down, that will be f double prime of 1 will give us 6 minus 2, which is 4, which is greater than 0. Concavity is up, so therefore the function has a minimum at t equal to 1. Let us check at t equal to negative 1 over 3. So f double prime of negative 1 over 3 equal to 6 multiplied by negative 1 over 3 minus 2. And that will be equal to negative 4, which is less than 0. It implies that there is a maximum point at t equal to negative 1 over 3. So now we're done with the maxima and minimum values. Now it's time to check for the inflection point. To find the inflection point, we have to set f double prime of t equal to 0 and solve for the value of t. So f double prime equal to 0 implies that 6t minus 2, which is f double prime of t equal to 6t minus 2. We have to equate 6t minus 2 to 0, and if we solve, we will figure out that t equal to 1 over 3 is a possible inflection point. But then we have to check to its left and to its right and see if the concavity changes. If it does, then this point is an inflection point. Okay, so let's take a look at to the right of 1/3 is 1. So we're going to go ahead and check f double prime of 1, and that's going to give us 4 greater than 0. That means the concavity is up. And then let's take a value to the left of 1 over 3, and that value is 0. So f double prime of 0 is going to be equal to negative 2, and that's less than 0, and that's concaving up. Since we have a change in concavity between t equal to 1 over 3, then t is an inflection point. Therefore, we'll summarize. The function has a minimum value at t equal to 1. It has an inflection point at t equal to 1 over 3 and a maximum at t equal to negative 1 over 3. And if we check on the options, we can see that the correct answer is option number C. Let's get to For this question, let g be a polynomial function such that g double prime of x equal to x plus 2 multiplied by x squared minus 10x minus 24. Find the x coordinates of all the inflection points of the graph of g. These are the possible answers. Let us search for the correct one. G double prime equals to x plus 2 multiplied by x squared minus 10x minus 24. We can go ahead and rewrite it as follows. X plus 2, we will leave it as this, and then we will look at this quadratic equation and factor it into two factors. That will give us x plus 2 multiplied by x minus 12. Now we have to look into equating this to 0. If we equate the equation to 0, it will imply that g double prime of negative 2 equal to 0 because it's a solution, and g double prime of 12 also equal to 0. That means at x equal to negative 2 and at x equal to 12, there is a possibility that both are inflection points, or one of them is inflection point, or none of them inflection point. So we have to go ahead and do the test. Therefore, the function may have inflection points at x equal to -2 and x equal to 12. We're going to go ahead and visit the left of -2 and the right of -2. The left of -2 is -3. The right of -2 is -1. So g double prime of -1 equal to -13 less than 0, and g double prime of -3 equal to -15 less than 0. We can see that we check to the left of -2 and to the right of -2, and both of them, they are concaving up, so there is no inflection point for x equal to -2. Now we will go ahead and check in the same way x equals to 12. So g double prime of 11, which is to the left of 12, equal to -169 less than 0. Less than 0, that means concavity is down. So it looks like we have to check also to the right of 12. And that's g double prime of 13. And that's going to give us 225, and that's greater than 0. So there is a change in the concavity around x equal to 12. Therefore, the implication is that an inflection point is at x equal to 12. There was none at x equal to -2 because there was no change in the concavity around x equal to -2. So the summary is that the correct answer is C, where it says only 12 is an inflection point. -2 is not inflection point. Next question. The function f of x equals to 3x to the power 5 plus a x to the power 4 plus b x to the power 3 has inflection points at x equal to 0, x equal to -1, and x equal to 1. Find the values of the constants a and b. These are the possible answers, and we have to look one more time to the or for the correct answer. Here is the function repeated for convenience. We have to take the derivative. First derivative is 15x to the power 4 plus 4a x to the power 3 plus 3b x squared. Now we have to take the second derivative. The second derivative will give us 60x to the power 3 plus 12a x squared plus 6bx. Now we have to go ahead and plug in, instead of x, -1, because we are told that these x equal to 1, x equal to -1, and x equal to 1, these are the inflection points. So we start with -1. So f of -1 equals to, we have 60 multiplied by -1 to the power 3, that will give us -60, plus we have 12a multiplied by -1 square, that's going to give us 12a without changing the sign, and then we have 6b multiplied by x, and x is -1, so we will have -6bx, and that's why we're subtracting it. That's equal to 0. And we could go ahead and plug in 1 in the same way, but then this time when we plug 1, x to the power 3, 1 to the power 3 is positive, so we will retain 60 without a negative in front of it. And obviously, instead of x squared, we will have 12a without any change, and also over here we will have plus 6b. because there is just x and we have to replace it by 1. So this is 6x. If we add up these two equations, okay, then we will have negative 60 goes with 60, and then 12a plus 12a will give us 24a, and then negative 6b and positive 6b will cancel each other. So that means 24a equal to 0 implies a equal to 0. So that is the first coefficient. Let's look for the second coefficient. F double prime of 1 equal to 60 plus 12 multiplied by 0 plus 6b equal to 0. This implies that 60 equal to negative 6b, and that implies b equal to negative 10. What we did is the following: f double prime of 1, and we said this is equal to 60 plus 12 multiplied by a, and we already decided that a is equal to 0, so this term will go, and then this is plus 6b. So we have just one variable here for this equation, and that implies 60 equals to negative 6b, and that implies b equal to negative 10. As such, we have a equal to 0 and b equal to negative 10, and if we look at the options, we will find that this is option number D. Let's move on to the next problem. For the last problem, we're given pretty much a graph, and we were supposed to figure out which of these functions matches the graph. So what we're going to do is the following. We look at A. A has a vertical asymptote at x equal to negative 1. The function doesn't, so A doesn't qualify. Limit B as x goes to infinity equal to 1. That's not consistent with the figure or the graph, so B is disqualified. Evaluation of D at x equals to negative 1 result in the function equals to plus 2.5, which is not consistent with this function also. Evaluation of E at x equal to negative 4 gives negative 1.28, and this is not consistent also. So none of these is consistent with the graph. That means A, B, and D and E, they are all disqualified. None of these is consistent with the graph. On the other hand, C is the only function that's consistent with the graph. That's it. So the correct answer is C, and this ends this. This is the end of the video. Thank you for watching.